So hello friends, so to start with the next lecture, that is transformation, and in the previous lecture we have learned about how to prepare competent cells and transformation. Here today we will learn transformation. What is transformation? Transformation is transferring a genetic material to a cell. That is transformation, and that is transformation in simple language. So whenever a cell has to take the DNA, it should be competent. And in the previous lecture I have explained you how to prepare a competent cell by conventional method. And if you are working with transformation by calcium chloride method, then you have to prepare your cell by using calcium chloride. And if you are working with the electroporation, or if you want to go with the electroporation, then you have to prepare your competent cell by slightly different method, and that I will explain if you want to learn. If we go with the transformation and calcium chloride method, which is conventional method, easy to work with. So transformation is like you have to see how many transformants or recombinants or positive clones you are getting after transforming 1 microgram of plasmid. So suppose if you are having 1 microgram of plasmid, 1 microgram of plasmid, and you need to transform that plasmid. So if you are getting 10⁻⁷ cells or colonies or recombinants positive, that means you have very high transformation efficiency. So what is transformation efficiency? Transformation efficiency is how many cells or positive cells or recombinants or transformants you are getting when you are transforming 1 microgram of plasmid. And that is affected by either your type of competent cell methodology, means your cells are good enough to take the DNA, and the second is transformation method. If you have some if you have not proceeded the cell or transformation in a scientific manner, then your transformation efficiency will be affected. So for transformation you need to have some important things you should be prepared in advance. One thing is you should have competent cells. So competent cells, as I have explained you in the previous lecture, that you can store at -80 degree, or they are maybe at 4 degree, or ice freshly you have prepared in the previous day, means 1 day before after your transformation, means आपने transformation से एक दिन पहले जो आपने cells बना रखे हैं, and you have preserved those cells on ice, those cells you can use. Then second, you need water bath, which should be calibrated water bath, and at 42 degree, and it should be calibrated. Calibrated means you should know the error in the water bath. So what you will do, if it is digital, even then you have to measure the temperature of the water which is present in the water bath, and it should be at 42 degree. The third thing is you should have good ice. It should not be watery ice, because you have to keep the cells for long time, so you need to have good ice. And then you need to have your medias, media, that is LB media or SOC media. SOC media is nothing, it is a media, SOB media plus glucose. When you are adding glucose to the SOB media, then you will have SOC media, which is used for your recovery. So like that, you should have all those things prepared in your hand. So to start with the procedure, of transformation, before starting the procedure, I want to tell you some important control for the transformation. There are three controls which should be used when you are performing transformation. So what are the control? One is you should have no DNA. In one vial you should not add any DNA, but the procedure should be followed same for this no DNA plate, or it will contain only competent cells. And then you should have digested plasmid, which you have prepared your plasmid for the ligation. The digested plasmid should be one of your control. Third one is you should have uncut plasmid. The plasmid which you want to transform, the uncut form should be there, and the quantity or the amount or the concentration you should know. And then you have the fourth one is, it is not control but it is your gene ligated plasmid. Gene ligated plasmid, in which your gene of interest is ligated, and now you have to transform that plasmid. So all three control along with your gene of interest, all four condition, 4 vials you have to keep for the transformation. Whenever you are working with, either you are working with your calcium chloride method or electroporation method or any other transformation step, you should have all these controls. This is your negative control, this is your just to check the digestion, and this is your positive control, this is your gene of interest which is ligated in the plasmid. So all these 4 conditions you should have in your hand. So plasmid is ready, competent cells are ready, now you have to do transformation. So you have to start your transformation. So what you have to see, you have to measure the temperature of the water bath. It should be at 42 degree before you are going to start your transformation. The first step is just take a full bucket of ice. It should has ice, and it should not be watery, means water should not be there. So just place your 4 vials. One is no DNA, one is uncut, one is digested, and one is your gene of interest. So they have competent cells. If you are taking out the competent cell, glycerol stocks of competent cell from the -80, even then it's okay. If you are working with fresh competent cell, even then it's okay. So just place your all 4 MCTs on the ice, and then add either 1 microliter of plasmid or 5 microliter or 10 microliter. Whatever ligation mix you are using or you want to transform, you should use either 1 microgram of plasmid for uncut, and or 5 microliter or 10 microliter which you have set as a digestion or ligation mix for the gene of interest. So you have to use, or you can use one because the concentration of uncut, you should know the concentration of uncut, then only you can measure the transformation efficiency. So once you have added, you have to add all the plasmid into this. You don't have to add in no DNA but in this. So you have to just add, and you don't have to add anything, any DNA in the no DNA vial. So one thing, remember one very important thing, you just label all 4 tubes before you are going to start your transformation, because once you have not labeled, or suppose seal the label with the sellotape, transparent sellotape, so that you can visualize the name, or you can recognize each vial, otherwise it will create confusion at the end. And because you are placing your vial on ice, you are placing your vials in the water bath, so if you have to label it. So how you can label? You can label like no DNA, you can label it digested DNA, you can label it uncut, you can label it gene of interest, that is X gene plasmid. So like that you can label all the tubes and cover it with the transparent sellotape, so that you should not have any confusion at the end. So once you have placed, you should not move these tubes, because as I will explain you that the negative charge will attract the positive charge, because calcium is there, so calcium will attract it towards negative, and calcium also attract your DNA molecule. So now DNA molecule is in very close proximity to the membrane. So now what you have to do? We have to give heat shock, because as the calcium is bound to the membrane, it will change the membrane potential, it will reduce the negative potential of the membrane, and now the membrane is slightly porous. So as it is slightly fragile or very porous, so as you give the heat shock, the DNA molecule will get entry into the cell. So your DNA, plasmid DNA will get entry into the cells. So heat shock कितने पे देना है हमें? 42 डिग्री पे. 42 डिग्री पे हीट शॉक देना है for 90 सेकेंड. For 90 seconds. So just give heat shock. You just take out the tubes, place those tubes in the water bath, and then start the timer. As the 90 second is over, once the 90 second is over, what you have to do? You have to give the cold shock now. क्यों देना है हमें cold shock? As I have explained you, heat shock हम देते हैं ताकि cells membrane खुले and cells will get entry into this. Now you have to give the cold shock. So what you will do from the water bath, you just immediately as the 90 second is over, you just take out the tubes and place on the ice. Immediately you have to place on the ice. Some papers they say 2 minutes is enough cold shock. Some studies they say 4 minutes, 5 minutes, 10. But if you give 10 to 15 minutes, that is more than sufficient for the recovery. So cold shock, what it will do? It will help in maintaining or reversing the negative potential. So the negative potential will increase as the cold shock treatment is given. So जैसे ही उसका negative potential दोबारा normal आएगा, दोबारा अपने उस पे आएगा, then the membrane will be closed now. As the membrane is closed, your plasmid will not come out. Right? But because of heat shock, because of this cold shock, now the cells are in shock. So the cells require time to repair themselves. So the fifth step is you have to add 1 ml of either SOC media or LB media. आप दोनों में से कोई भी मीडिया 1 ml मीडिया, SOC मीडिया और LB मीडिया आप ऐड कर सकते हैं. SOC is better because it has high glucose and glucose is a carbon source for cells. So cells will repair itself very fast. At this recovery phase, because you are keeping these cells in 1 ml SOC media or LB media at 37 degree for 1 hour, the cells are not dividing or they are very low in dividing state. But they are metabolically active. So they will repair themselves very fast. Right? So this is known as your recovery phase. What it is known as? This is your recovery phase. Recovery phase for the cells. Now the cells have recovered in 1 hour. Now you have to plate out the cell. Now what you have to do? You have to plate out the cells. आपने कोल्ड शॉक दिया कितनी देर के लिए? 10 to 15 मिनट के लिए, which is more than sufficient. After cold shock, then immediately you have to add SOC media, warm SOC media or LB media. Then place the tubes at 37 degree for 1 hour. This is recovery phase. Now plate out the cells. अब आपने plating करनी है. And for plating, you should use LB plates. You have to use LB plate with appropriate LB plates plus antibiotic. Suppose if you are working with ampicillin resistant gene, if your plasmid has ampicillin resistant gene, then you have to add ampicillin. If it is kanamycin, you have to add kanamycin, like that. So like that you have to see which antibiotic resistant that plasmid having the gene. So according to the gene, you have to add your antibiotic to the LB plate. Remember one thing, the concentration of antibiotic should be appropriate. Otherwise, you will get some kind of contaminating bacterial colonies और air aerobic जो air में जो आपके bacteria हैं, hands में जो आपके bacteria हैं, they will grow. And one more very important thing, you have to work in biosafety cabinet 2. Whenever you are plating your plates, you should be biosafety cabinet 2. So you have to plate out. So while you are plating, you have to, suppose this is your 1 ml containing cell suspension after recovery. You have to spin down at 5000 rpm for 5 minutes. Then remove remove the media and then add 100 to 150 microliter of LB media to the cells. अब आपके पास पैलेट बन गई, आपने उसमें इस पैलेट में आपने 100 to 200 microliter of LB media ऐड करना है and then resuspend the cells. Gently you have to resuspend the cells. आपने बहुत फोर्सफुली पाइपेट आपके सेल पैलेट को मिक्स नहीं करना है because this competent cells are or these transformants or the cells are very fragile and you have to just tap it with the hand and mix it and just plate out on the agar plate. There are people, they are using two different type of spreader. You can use ready to use spreaders, that is for just one time, and you can use glass spreaders. While you are using glass spreader, that time you have to sterile your glass rod properly, otherwise the contaminants you will have many contaminants in all the plates, so you will not have successful transformation. So to avoid any contamination among the plates, you should sterile your glass spreaders. So you can work with either your ready to use spreaders or glass spreaders. So that type of spreading you have to learn and you have to do. So next day, now keep your plates at 37 overnight for the growth of colonies. So I have told you 4 plates. One is no DNA plate. The second, remember one thing, you have to label the plates also, otherwise you will get confusion. So no DNA along with the date. No DNA, then you have to you have digested plasmid, then you have uncut plasmid, and then you have gene of interest. Minimum these 3 controls and your test sample gene of interest plus plasmid, ligated plasmid. So what you will see next day? In no DNA, if your transformation procedure, if your competent cell preparation is okay, then you will not see no colonies. आपको यहाँ कोई कॉलोनी नहीं दिखेगी. If your digestion is complete, then you will not have any colonies. If your digestion is complete, then you don't have any colonies here. But if your digestion is incomplete, then you will have colonies. You will get colonies here. And if digestion is not complete, then you will get same colony number here also. And you might miss the your gene of interest or ligated plasmids. So because आपने क्या किया, आपने अगर आपका डाइजेशन कंप्लीट था तो यहाँ पे आपके कॉलोनीज नहीं आई, बट आपका डाइजेशन जो था कंप्लीट नहीं था, दैट मीन्स अनकट प्लाज्मिड इज आल्सो देयर which is contaminant for this plate. So it will grow here because it has ampicillin or your antibiotic resistant gene, so it will grow and you will get same number of cells in like gene of interest plate and this digested plate. So your transformation will fail. And this uncut plasmid will tell 2 things. One, it will tell the transformation efficiency. You can calculate with the uncut colonies. You will get colonies in uncut. So what you will interpret? You will calculate your transformation efficiency from this plate. And the second, you will see if you will not get any colonies, no colonies, then that means your transformation protocol is not okay. Your transformation protocol is not okay or your competent cells are not good. That's why your transformation failed. So uncut से आपको 2 चीजें पता चलेंगी, transformation efficiency and the transformation protocol is working fine or not. Then gene of interest, as I have explained you, if you don't have any colonies here and colonies here, that means you have chance to get positive recombinants here, right? And if you have same number of colonies here and here, that means your transformation is not okay. So you have to start from the beginning. So this is all about transformation protocol. You just go through this transformation protocol, you just read the Sambrook and you will find the similar protocol there also. So if you have any queries, any question regarding this, you can ask me and you can write to me. So in next lecture, what we are going to see? We are going to see how to screen out these positive clones, how to screen out or how to screen out the recombinants or the clones or the transformant from this gene of interest plate. आपने 37 पे रख के आपके पास clones आ गए positive, and positive means negative or positive. You have to screen out. For that you need to have one procedure. And then once you have screened out your clones, how to make replica plate, and then you have to see how to do plasmid isolation. So 2 things we'll learn in next lecture, that is plasmid isolation. Thank you.